నువ్వు మాట్లాడు. నేను అంత ఎక్కువ వస్తుంది
దగ్గర ఉంటే అట్నే వస్తుంది.
హలో, ఇది వాడలేదు. ఇంకోసారి పెట్టకూడదు వాట్సాప్. చెప్పినా ప్రిన్సిపల్ నోట్ ఇచ్చింది. ప్రిన్సిపల్ మ్యూట్ చేశాను. మ్యూట్
చేసిన
అది
This is 2-week program, mechanical program. Andal mode focus panam. Pragati ipo pesitanga andal mode focus panam.
इधर आओ।
Online coaching. Meenakshi. Course and Dr. Meenakshi Rathore.
गुड मॉर्निंग डॉक्टर शिवा।
Good morning, madam. After long.
हाँ, कैसे हो?
ठीक हूँ मैडम, ठीक है।
चलो अभी मैं वीडियो स्टॉप करती हूँ एंड ड्यूरिंग प्रेजेंटेशन भी वीडियो स्टॉप कर दूंगी सो दैट सिग्नल ओके रहेगा फिर, ठीक है ना?
हाँ ठीक है, अभी प्रेजेंटेशन करने समय स्टॉप कर लीजिए।
हाँ हाँ ठीक है।
एक मिनट मैडम। म्यूट చేసి పోస్ట్ చేశారు సెల్ఫ్ మ్యూట్ ఎక్కడ రాస్తున్నాం 20 ముందే ఇంకా స్టార్ట్ చేయొచ్చు स्टार्ट करेंगे मैडम और थोड़ा टाइम लेंगे।
आई एम रेडी, आप लोग देख लो, जब भी स्टार्ट करना होगा तो वी विल स्टार्ट एंड आई विल टेक अराउंड 1.5 आवर।
हाँ या मोर देन ओके। मैं थोड़ा इंट्रोड्यूस करता हूँ, उसके बाद आप स्टार्ट करते हैं सेशन।
ओके 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 श्योर।
Good morning all participants. Today's last day we reached to end. So today's speaker Dr. Meenakshi Rathore. She is MTech PhD from IIT Delhi and she is expert in she worked in the Renewable Energy Research Institute more than 5 years. Later she started their own consultancy for energy efficiency and green buildings in Raipur. Government related projects she executed government related projects. She have vast experience in the energy efficiency and green buildings, but and she have regarding research, she whatever the research she did on the energy efficient buildings, same research she extended and she is at present she is running own consultancy. And one word, why? Because earlier also I mentioned gratitude, who are help for our excellency, we have to show the gratitude. Earlier I given one name, that is Dr. Manoj Kumar Gupta. Without him my PhD is not started. Without Dr. Meenakshi Sahu at the time, my PhD will not complete. Why? Because I am in a blind mode. I am unable to write the program in MATLAB for solar simulation. Within 2 hours, she completed that program. This in the PhD, we got the colleagues. All colleagues not treated as a competitor. All colleagues, they are helping for enhancing our excellence. Because of that only, we all team, all successive, all got the doctorates, all in a settled position. So I have to show my gratitude to my senior, Dr. Meenakshi Sahu, madam. At present, Meenakshi Rathod. With this small introduction, she have vast experience in energy efficient buildings and green buildings. So you can gain the knowledge. After his presentation, you may ask whatever, any types of questions related to energy efficient and green buildings. With this small introduction, I am handovering the session to our senior Dr. Meenakshi Rathod. Madam, now your session is yours, madam. Up to 11:30, yours only.
Okay, Dr. Siva, thank you so much for that introduction. Thank you so much. Uh, you was a great colleague, and you also helped me a lot during my PhD. Very good morning, everyone. Now I'm sharing my PPT. Just sharing my screen. Okay. Okay, let's start. As Dr. Siva told, I'm Dr. Meenakshi Rathore. I'm from Raipur, Chhattisgarh. Dr. Shiva has given my introduction. Just a brief, I'm also giving. Basically, I am a civil engineer, graduated from NIT Raipur. Then I did my MTech in energy studies from IIT Delhi. Then I pursued my PhD in energy efficient building from IIT Delhi itself. And then I was working with Terry, New Delhi, and I was energy consultant there. And I have handled so many Griha projects and green building projects. Then I moved back to Raipur, as Raipur was my hometown, and started my own consultancy. And right now I am a green building consultant and handling so many green building projects in the Raipur and in various parts of the India. And also I'm a Griha patron. Griha is a green building rating system, and I'm the Griha patron and Griha certified professional. And I give training to so many government officers and students and faculties regarding the green building. So, being a green building consultant, today I will talk about green building concept, case study, and certification. So, we will start now. These are some news reports I got from Google and from the newspapers. This is the picture from the Gujarat showing that water is scarcity in the India. So you can see if we have not saved water today, tomorrow we will be in this queue. Another news reports about the Chennai water crisis. So you can see the headlines: Chennai water crisis, a wake up call for Indian cities. India faces worst ever water crisis. India's twin cities, Hyderabad and Secunderabad. Life in India's first city that is almost out of water. So these are the some news reports. Now another picture showing a India map saying 54% of India faces high to extremely high water stress. Another photographs showing the importance of one mature tree. You might be seeing this type of photograph in your social media, WhatsApp, Facebook, Instagram, etc. So I don't think I need to explain what that image is saying. So these are the scenario which we are facing right now in India and outside the India. So now we come to energy part. What is the Indian energy scenario? India is the third largest energy consumer in the world after USA and China. Out of that energy, 37% of electricity, nation's electricity, is consumed by the building sector. So, as we have seen that water scarcity, global warming, climate change, and the energy scarcity, energy's importance. So, so here we are talking about the green building. So, what is a green building? As compared to a conventional building, here conventional building I am saying to all the standard building which we see around us, like our houses, offices, residential complex, malls, theaters, all the buildings, standard buildings. So as compared to a conventional building, a green building uses less energy, water, and natural resources, because in the green building we take care of the energy optimization and water optimization, and we disrupt minimum natural resources. Green building creates less waste because we do the waste management in the green building. We reuse and recycle as much as waste possible. Green building is smartly located and built with little impact on the environment. So we take care in the green building, we take care of the orientation, site planning, existing water body, and so many things. So it creates very little impact on the environment. Because in the green building, we take care of the thermal comfort, visual comfort, and acoustic comfort, so that it is healthier for the people living or working inside it. So what are the key components of a green building? These are site planning and management, material use, energy management, indoor air quality, and water management. So, in the site planning and management, the site planning for green building construction are performed in such a way that the design and construction strategies are sustainable and efficient. When we see about the site planning in the green building, then we ensure first maximum disruption of the site, and second maximum uses of microclimate features. Here we follow a collaborative approach for the planning, where the owners, engineers, architects, contractors, and the other important stakeholders come together to develop a sustainable design process, which helps to combine valuable inputs from different expertise. So, we develop a sustainable site planning based on the discussions and inputs. So, if we do the proper site planning and management, it creates less impact on the environment while meets the project goal of the client. So, the site plan must fit to project parameters without compromising environmental concerns. Then the another key component is material use. When we use the different type of material, like material in the wall, in the roof, and in the openings, and so many other materials, then we consider some points like it should be locally available, if possible it should be recyclable, it should have recycled content, it should be durable, thermally efficient, and one of the most important, it should be cost effective. So I think some noise is there. Okay. So these are the material use. Then the third component is energy management. In the energy management, first we optimize the energy performance. For that, we model the building in the softwares and we do simulation, computer simulation, and so that we optimize the energy management and we reduce the we reduce the energy consumption of the building. And then fourth parameter is indoor air quality. Improved indoor air quality is one of the critical component of the green building. In the indoor air quality, we consider the indoor air pollution, outdoor air pollution, ventilation, etc. And then fifth point, we come to water management. In this segment, as we have seen, we are having water scarcity and it is very critical in the India. So here we curtail or optimize the water demand by properly design the system. Here we do water recycling and water reuse, and also we use efficient plumbing fixtures. So these five elements together called the green building. So sometimes when we talk about this component, some people thought that green building is a rocket science and it is very difficult to construct. But yes, it is a technical things, but it is not a rocket science. We are using so many green building features since our ancient times. So I will show some examples of ventilation techniques and water storage techniques for that. So first we come to ventilation techniques. This is the picture from Taj Mahal. When I have visited Taj Mahal, then I clicked this picture. This shows the ventilation techniques. They used that people use this type of jali for the ventilation. Then some old fort, they are using, they are also using this type of jali for the ventilation. Another photographs, again, they are using the jalis and window for the ventilation. And in modern India, we are having this type of jalis, exhaust fans, and other type of equipment. And sometimes we incorporate daylight and ventilation in our interiors like that. And for water storage. Water storage in ancient India, if we talk about ancient India, then we have pond, lakes, well, step wells, and so many this type of things. And now in the modern India, we talk about rainwater harvesting. We are having overhead water tanks. So why I'm showing these pictures? I just want to tell that from the ancient India, we are using so many green building features. And now in modern India, we have improvised that features according to our lifestyle. Now I will show some clothing pattern, traditional clothing pattern. So you can see this picture. If I ask, these people are from which place? Then you immediately recognize and say that they are from the Rajasthan. So another question, how you have recognized? So answer is because of their turban. So the next question, then they why they use that turban over their head? So because in Registan comes under hot and dry climate. Most of the part of the Rajasthan comes under hot dry climate and they are having desert. So in the hot dry climate, they have harsh solar radiation over their head. So to protect their head, they use that turban. And you can see that most of the people use the colorful turban. So why they use that colorful turban? Because in Registan desert, they have all the area they have sand and almost no greenery. So to feel colors in their life, they use that colorful turban. So now another picture. If I ask same question, this fellow is from which place? You will recognize that he is from the Saudi Arabia. Then how you have recognized? Because of his getup. Again, with the same reason, to protect his body from the harsh solar radiation, he wore this type of cloth. He has full sleeves, high neck, and white color dress, because white color absorbs very less radiation and reflect all the radiations. So he weared like that. He wore this type of color and this type of getup. He has also protected his head with that white scarf, and he has covered his ears. So he is also wearing the getup according to his their climate. Another photograph, some Eskimos, they are also wearing the this type of cloth as per their climate. Some lady maybe from the northeast, she has also wore the same getup according to her climate, full sleeves, high neck, and protecting her head from the cold breeze. And she may put down her flap when cold breeze will come. So now another photograph. This is the modern India. If I ask the same question, these people are from which place? You may say that they may be from any place. They may be from Delhi, they may be from Mumbai, they may be from Bangalore, Hyderabad, Raipur, Singapore, any place. So what happened? Another photograph. These people may belong to be any place. They may be from any place of the country or outside the country. So what happened here? Now our clothes are influenced by the Western pattern. So here I'm not opposing the Western clothings. Even I like Western clothing. Dr. Siva knows that. I used to wear the jeans and t-shirts. So here just I want to tell that if that influence is up to our clothing only, then it's fine because it is our personal choice. But when that influence, that Western influence, come to our building, then it is very harmful. How? So this is another image by using the plenty of glasswork in the building. Nowadays, the construction of fully glazed commercial building facades, which is responsible for high energy consumption, has become a common architectural practice worldwide, irrespective of the climate. So, is it required for the Indian climate to use the plenty of glasswork in the building? So the answer is no, never. Why? Because we are in the tropical climate. India comes under tropical climate, and in India, most of the part of the country requires cooling all over the year. So we don't need that so much of glass works. So because glass trapped the heat, and to remove that heat, we need so many cooling load. So why it trapped the heat? Because the radiation that comes from the sun is shortwave radiation. When it enters to our houses, buildings, offices, etc., through the openings, and then when that radiation strikes on the inside surface like furniture, wall, etc., then these surfaces absorb the short wave radiation and emits the long wave radiation. So now we can say that that the short wave radiation that was coming from the sun is now converted into the long wave radiation, and the glass is opaque for the long wave radiation, and this is the greenhouse effect. We all know that. So now we can imagine that how much cooling is required to remove this excess heat and so much of heat. So without glass, building doesn't look good. Now the question, without glass, the building doesn't look good. It looks good. Another example, this is a green building. This is the first 5-star Terry Griha rated building. This building is situated in IIT Kanpur. And you can see that with the minimum use of glass, they have beautifully designed that building. And you can see the horizontal surface, that is the top roof here. You can see my cursor, I think. So at the top roof, from the top roof, we get the maximum amount of solar radiation. So they have used, in the top roof, they have used the pergola and even the solar panel, so that uh, they can produce the electricity. Even one more thing you can see, they haven't cut so many existing trees. Even they have included that incorporated that existing trees in their design. So it is a very beautiful building, and this is the green building, 5-star rated green building. Another example, this is Fortis Hospital. This is also a Griha rated building, green building. Here they have also used with minimum glass and beautifully designed that building. Another wrong practice in building sector which we do is no waste management. We have learned from the western countries, we have learned the use of glass in our buildings, but we haven't learned the waste management from them. However, we can do waste management by segregating it at the primary level by using the differently color coded bins. Another wrong practice in building sector is use of red bricks. We all know that red bricks is formed by the soil. We make red brick by the soil, and soil formed in the earth in 300, 400, even up to 500 years. And even the fertile soil uh, formed uh, formed to take 1000, 2000, even 3000 year, and we use that fertile or non fertile soil to make the brick. So it is really very harmful for the nature. Instead of that, we can use the fly ash brick or the brick made by any byproduct or the waste material. This is a table I took from the Google, because so many people asked me the advantages of fly ash brick over the red brick. So I put that table here. So you can see the compressive strength of fly ash brick. If it is properly made, then fly ash brick compressive strength of fly ash brick is very good as compared to the red brick. It has optimum absorption. Fly ash brick has even surfaces. All 6 surfaces are even and plane, so we can save up to 25% mortar. And we plaster the wall, then we can save up to 15% plaster if we use the fly ash brick. And during the transit, red bricks, so many red brick are broke down, so there is a wastage when we use the red brick. And obviously it is made by the soil, red brick is made by soil, so it is very harmful for natural resources. However, fly ash brick is the industrial waste, so we are reusing that. And in Chhattisgarh, as I'm from Chhattisgarh, and Chhattisgarh is an industrial place, so here fly ash is available in plenty, and it is cheaper than the red brick. Another advantages of fly ash brick, it is available in various sizes and even in the large blocks. So we can use it in the when we construct large boundary walls, etc. And we can save the manpower. So these was the wrong practices we do in the building sector. Now I will show the wrong practices we do in the city planning. So for that, I will show some snapshot of different cities which I took from the Google Earth. This is the Google Earth image, Chandigarh. Google Earth, Google has taken this picture in 2010. So you can see, and we all know that Chandigarh is a very planned city. You can see here grid pattern, proper road network, and so much greenery. Now I will show you another image of my city, Raipur. This is a well-known place of Raipur. Uh, Image has taken in 2003. You can see there is no grid pattern, no road network, and very little greenery. This image is taken in 2003. Now, see carefully. I will show the image of the same place in 2010. Now this is image of 2003 and this is image in 2010. What we have done? We made a concrete jungle. So why I'm showing? We have not learned anything from that city like Chandigarh, which is very planned city. We have mess here. Though Chandigarh is about 1,000 kilometers from Raipur, far from the Raipur, we have not learned from the nearby city Bhilai. You know Bhilai steel plant. So Bhilai is the nearby city around 30 kilometers from the Raipur. We have not learned anything from the uh, we have not learned anything from the Bhilai. So you can see this is just a second. Some message. Good morning. Okay. So you can see I will show you the uh, okay. So this was the Chandigarh in 2010, Raipur in 2003, Raipur in 2010, and Bhilai in 2010. So why I am showing this? I just want to tell that if we do anything, if we construct any building, a small office, big building, big residential complex, office complex, mall, or if we plan a city, we have to plan everything at the design level itself. Otherwise, you can see what may happen. So this was my concern. But some people tell that if only I do, then what will happen? So I just want to say that we all are connected, we all are intact, and we all are undivided. All the water, air, everything, all are connected. And the latest example, COVID 19, we all know that it is spread all over the world. So, and we know that a small effort makes big difference. So, we can do very good things at the small level only because we all are intact, we all are undivided. Sometimes we think that we are not taking gas, oil, or coal from our place. It is they are taking in the they are excavating from other countries. But the earth is only one. We have seen that earth is only one. We all in the same earth. We all using same air. We all using same water. So if we damage earth at any place, it will affect to another place also, because if we excavate the things, if we excavate anything, it will damage the earth. If we are excavating coal, oil, or gas, then it will they all the material has been inside the earth to balance the earth, to balance the gravity, and to balance the earth's magnetic field. So we are excavating all of them, and result is here, weakening of earth's magnetic field. This is the report from European Space Agency ESA. They're saying that Earth's magnetic field has been weakening across a wide stretch of area. The magnetic field has lost nearly 9% of its strength in the last 200 years. And the what is that Earth's magnetic field? You can see here Earth's magnetic field is a complex and dynamic force that helps in sustaining life by shielding us from cosmic radiation and other charged particles from the sun, and we are damaging them. So, it was some part which I wanted to tell. Now, we again come to our green building. Now, we come to the case study. When we do any green building project, so some stages are involved in that. First stage is the design. As I told you, design is the very important part of the any project, whether it is green building or not. So it is very important. So in the green building also, at the design stage, we decide everything and we freeze everything from the excavation level to the operational and maintenance level. So we do everything at the design stage. So after that design stage, we start construction. From the excavation, we start the construction, then operation, and then maintenance. These all four stages together called the green building. So this is my case study. Here in this case study, I will take one part of the green building, that is the energy part. And this is a building situated in Delhi, some government project. So this Delhi comes under composite climate, and you can see this is the G+1, ground+1 building, and about 50% of the area of the building is air conditioned. This building we have designed when I was working in Terry. So when the building has come to us for the energy part and the green building part, then we did some improvement in the building. So you can see in the left side of the slide, these were the improvement we did in that building. So the first improvement we did is the orientation. So, what is the orientation? The term building orientation simply refers to the compass direction of the building faces, and it is one of the most important step. Here, orientation is the positioning of a building in relation to seasonal variations in the sun path as well as prevailing wind patterns. So, according to the sun path of New Delhi, we oriented the building because good orientation can increase the energy efficiency of the building and make it more comfortable to live in and cheaper to run. So after positioning the building and making good orientation of building, we started to work on the shading. In the shading devices are related to solar movement. As we have designed the shading, we have to see the sun path of the building. And we all know that we live in the northern hemisphere of the earth. So in the northern hemisphere, the sun rises in the east and by moving towards the south, sets in the west. Excuse me, my voice is okay, Dr. Shiva?
Okay, ma'am, you can continue.
Okay. So to keep that sun path in the mind, and as per the sun path analysis of the location, we designed the fins. Fins means vertical component of the setting device, and chhajja. Chhajja means horizontal component of the setting design. So we have designed that fins and chhajja so that we minimized direct exposure of the sun and usage of electricity for cooling purpose. Then after orientation and shading, we moved to WWR. WWR means window to wall ratio. Window to wall ratio means total area of the window divided by total area of the external wall. So it is an important variable affecting energy performance. So it is an important factor which affect the energy performance of the building. So we here we optimize the window size. So if we took very large window, then it takes so much heat and we have to our cooling load will increase. And if we took very small size window, then there will be visual discomfort and we will get very small daylight. So we have to optimally design the window size also. So in the WWR we do that. Then we come to ECBC glazing. So first we talk about ECBC. You might be knowing that ECBC is a Energy Conservation Building Code. It was launched in 2007 by Ministry of Power, Government of India, and then it is revised in 2017. ECBC sets minimum energy performance standards for commercial building. It includes energy performance standard for building envelope, heating, ventilation and air conditioning, lighting, service water heating, electric power and distribution. So as per the uh, ECBC glazing in the fourth step, ECBC glazing, uh, as per the standards given by the ECBC, we have chosen the glazing as per their VLT. VLT means visualized light transmission, U value of the glass, and solar heat gain coefficient or solar coefficient of the glass. We have chose that glazing pattern. Then we came to ECBC roof. The roof we construct at the top of the building plays a very big part in the building's overall efficiency and ability to control heat, because it took so much heat, maximum heat from the sun. So we have designed the ECBC roof, and we have decided the insulation, which insulation will be good for that building. So we have decided as per the ECBC. Then we came to reflective coating. We suggested them reflective coating over the top of the roof to reflect more sunlight from the surface, which reduce the amount of heat absorbed at that horizontal surface. On top of that, a reflective roof coating also aid in creating more comfortable indoor environments and play a role in prolonging the life of roofs and roofing material. Then after that we came to ECBC wall. So similar to ECBC roof, we have taken um, specification for the ECBC wall, and we designed the external wall according to the ECBC norms, the value U value given in the ECBC. So then we came to LPD. LPD means lighting power density. It is the lighting load in watts per square feet or per square meter. Then after that, uh, we improved the chiller. We know that chillers are used in building to provide cooling. So initially, uh, they have used the air cooled chiller, and we designed the cooling, and we suggested them water cooled chiller and the efficient chiller. So after that improvement, we did so many 1, 2, 3, 4, 5, 6, 7, 8, 9 improvements we did in that building. So initially, when the building has come to us, its cooling load was 113 ton of refrigeration. Initially, the cooling load was 113 ton of refrigeration, these improvements, it reduced down to 49 TR. So we have reduced in the design stage only. I'm talking about design stage only. In the design stage, we have reduced more than 50% of cooling load by doing that improvements. So this was the case study for the energy point of view. Now I will take another case study when we do in the construction, what we do during the construction in the green building. So this is another example of the building. The building name is Paryavas Bhavan. It is situated in Naya Raipur. Naya Raipur is a new city. They have uh, developed after the Chhattisgarh has been declared as a capital. So it is called Naya Raipur. So that building is situated in the Paryavas Bhavan, and I was consultant there. I was helping the contractor to implement the green building norms. So that building has three government departments. First is Naya Raipur Development Authority, then Chhattisgarh Environmental Conservation Board, and Chhattisgarh Housing Board. It is there is three blocks in the building. This is a 3D view. You can see these are the three departments, one department, two, and the three department, and all are interconnected. So, and the built up area of the building was about 15,000 square meter, and the building is already completed, and they are using that building now. So we have when the contractor started the construction, so we suggested them to test the soil for its fertility. So he has tested the soil for its fertility, and the soil found fertile. So the team has excavated 150 of the top fertile soil, and preserved that soil and protected it. You can see they have, yeah, fencing is there to protect it, and they have preserved this soil by doing the vegetation over it to reduce the soil erosion. During the land worship, some minister uh, were there, and they did some plantation. So we have protected all that plants and trees. These are the images. So this is a labor camp. You can see very neat and clean and spacious labor camp. So because labor is also labor camp and labor sanitation and safety is very important in the green building aspects, and even it is written in the national building code also. So this is the labor camp, and we have trained the ladder that the team has trained the labor to put all their waste in the waste bin only. So these are the image. The team has provided a safe and clean and hygienic drinking water at the camp, at the labor camp, as well as at the site. So this is the drinking water facility at site. There's this image, that green net, because in the Raipur, we get harsh solar radiation in about 8 months, 7 to 8 months in the year. So they have put the green net here, and they have put the earthen pot for the so that labor can get the cool water, cold water. And here also you can see date of cleaning and due date of cleaning is written here, so that supervisor who supervise the hygiene and cleanliness of the water, they might know that the that tank has been cleaned or not. The team has provided a separate toilets for the female laborers, and they have taken care of the proper drainage and the proper water facilities at that place. When we do construction, then that air pollution and noise pollution is very critical for the surrounding buildings and the surrounding people. So to avoid and to overcome that air pollution and noise pollution, we have made a 3-meter high barricading all over our side boundaries. So you can see they have used that tin sheets, and also they have used that empty cement bags, and they have made hole here so that wind can goes, and to avoid that falling hazardous. So they have protected like that. You can see that 3-meter high boundary wall. Dust control to inside air pollution, to avoid inside air pollution, the people used to do the sprinkling of water to control the dust. And when not in use, then when they not use that sand or any fine aggregate, then they used to cover that material. Now the wheel wash system, we have introduced that wheel wash system in our building. Wheel wash system can be installed on construction site to enable the wheels of trucks and other vehicles to be cleaned before leaving the site. This wheel wash system helps to control and reduce the air pollution caused by the mud, slurry, and other pollutants carried by the tires and deposit on the public road. So to avoid that, we have made wheel wash system at our site, and this is the image of wheel wash system. In the construction site, we have so many construction material, and we have properly stored all the materials, and designated place has been given to all the materials. So this is the steel stockyard. You can see they have put the team has put that steel properly, and it is above the ground, so to avoid the rusting of that steel. And this is the sand, so that to avoid the wastage of sand, they have protected by the cement bags. They have put that sand in that empty cement bag and put here to barricade the sand to avoid the wastage of sand. These are the shuttering material. They have properly keep it all the shuttering material in the designated place, and they have covered it to avoid the moisture. In the construction site, we have so many types of wastage. So, as I told you in the very beginning slide, that we can segregate the waste at the primary level only. So, here also we have done that, and we have color coded bins, and we have also written, the team has also written the in every bins that what waste have to put in the which bins. So you can see here it is written in every waste bin. Since in the Chhattisgarh mother tongue is Hindi, so they have written in Hindi so that labor can easily read it, and that all color coded bins put in so many places in the construction site. So that was the primary level segregation. At the secondary level, they have made the scrap yard. You can see this is the wooden scrap yard. They have properly uh, keep that the waste wooden, and they have properly barricaded that all the wood waste. And this is another scrap yard, steel scrap yard, and the wood scrap yard at the back side of the site. You can see binding wires are here, some small pieces of the steels are here at the steel scrap yard. One very interesting thing, very good thing the contractor has done in the site. He has done an agreement with the scrap dealer, who came frequently at the site and took all the waste material from the site for the recycle and reuse. So you can see the image that scrap dealer is taking that wood, steel, empty cement bags, and like that. Now curing is very important part, because through the curing also, through the by the through the curing, very sometimes very water is wasted through the curing. So here we are using gunny bags like we do in so many residential or any building projects. So here also we have used the gunny bags, and they have set all the gunny bags properly, so to avoid the wastage of the water. So these are the part. Now the ponding system we do in our buildings, in so many buildings we do, when we cast our slabs, then we put the ponding to store the water. So here also we have made ponding. You can see here so many small pond has been made here to store the water, so to curtail the wastage of water. One more interesting thing the team has been done, when we cast any slab or beam or column, we put the date of casting, so that after 7 days or 14 days when we have to stop the curing, we have to remember when we have casted that beam or column, and after 7 or 14 days we have to stop that curing. But sometimes labor is illiterate, or he doesn't care of that date of costing, and he continue start that curing day by day, and up to 1 month and 1.5 month and up to 2 months also, and it is so much wastage of water. So one thing they have done is, after 14 days or 7 days when we have to stop the curing, the supervisor put a red cross mark, though, so that the person who has to cure that beam or column, he will know that he has to or she has to stop that curing. As I told you, safety is very major aspect of the construction site. So here, all the labor has been provided safety shoes, helmets, and the labor who has to work at height, he has provided safety harness, and it was mandatory to use that helmet, safety shoes, and the harness for all the laborers. Safety nets has been used at the height of the building to reduce the falling hazards. Since still in many places green building construction and green building implementation is new things, so to train the labor, the team organized so many camps and training programs so that they can educate the labor for the green building. So you can see the labor, they are celebrating National Safety Day, and in this photograph they are training the labor. For safety of the labor, they have put that signages. You can see signages are there, and it was it is written in the Hindi. As I told you, the mother tongue in Chhattisgarh is Hindi, so it is written in Hindi also, so that they can easily read it. And also, it is in the pictorial form because some laborers may be illiterate, so they can see that picture and aware about that. Safety things. This is the crutch they have made at near the labor camp, because in Chhattisgarh, the husband and wife both go to the site. Labor husband and wife both go to the site, and because nobody at the home, so they took their kid to the site, and we all know that it is very harmful for the kids to be there at the construction site. And also NBC also says that the kids below the 14-year age should not be at the site. So they have made a crutch for the labor children so that labor can go to the site for working, so that their productivity will also increase because they haven't take care of their kids at the site. And also what they have done, they have appointed a local lady for teaching them. So in this image you can see that that lady is teaching these labor kids. And in this picture they are celebrating 15th August, the Independence Day, at the crutch. So this was the some case study which I have shown you for the design side and for the from the construction side. Now I will brief. I will talk about green building rating system. What is green building rating system? So green building rates the building according to their greenness, how much green it is. So major rating system in India is GREHA, IGBC, LEED, BEE, EDGE, and GEM. So as I told you, I'm a GREHA patron. So being a GREHA patron, I will a little bit talk about GREHA. By the way, almost all the rating system are more or less similar. So almost all the similar. If you if you see what Griha says, then we can also understand what other rating system says. So what is Griha? The full form of Griha is Green Rating for Integrated Habitat Assessment. It is tool to facilitate design, construction, operation of a green building, and in turn measure greenness of a building in India. Griha is initially developed by Terry, and latterly it is endorsed by Ministry of New and Renewable Energy, Government of India, and then it is declared as a national rating system. Griha has 31 criteria, and these 31 criteria has 100 points categorized in different sections. These sections are site selections and site planning. Some sections are site planning and site selection and site planning, conservation and efficient utilization of resources, building operation and maintenance, innovation, energy, landscaping, water, and so many other points are included in that criteria. So as I told you, this is the Griha logo, and Griha highlights, as I told you, it is a set of 31 criteria having 100 points. Then if we implement that points in our building, then we get some points. So for example, the building gets the 25 to 40 points, then it gets the 1 point. If building gets the 41 to 50 points, 55 point, then it is rated as 2 star Griha rating. And similarly, with 86 or more points, it is 5-star Griha rated building. So this is the now this is a pie chart showing the weightage of that different sections based on our national priorities. So you can see that maximum 20% has been given to energy, then 17% has been given to water, then 14% has been given to sustainable building material, then 12% has been given to occupant comfort and well-being, then 9% weightage has been given to construction management, then 8% has been given to site planning and performance monitoring and validation, and then 6% has been given to solid waste management and socio-economic strategies. So these are the weightage has been given to each sections as per the our national priorities. So what is the rating process in the Griha? What is the rating process? So it is an online system. Everything we do is the online process. So initially we have to do the registration, online registration. In the registration we have to give the some details of the building, for example where the building is located, what is the site area, what is the construction area, built up area, and like that. So we have to give small some details of the buildings in the registration. Then they give the ID and password so that we can log in to their online portal. After the registration, client has to organize a orientation workshop. This is not mandatory part. This is optional. So client has to do that orientation workshop. In that orientation workshop, Griha officials comes and in that workshop all the client contractors, all the consultant, MEP consultant, plumbing MEP consultant, HVAC consultant, architects, and every other consultant come together, and Griha people train them and give all the details about the Griha and about the building and how to proceed with Griha criteria in that building. They discuss about that. And also in the orientation workshop, they ensure that for how many points we are going to start that building. So this is the registration and orientation workshop. And after after that, when we start the construction, during the when we do the civil construction work, Griha officials do site visit. This is the first site visit of Griha officials, and obviously it is for checking the building, monitoring the building. So they monitor the building and also they give their suggestion according to the Griha norms. So when the civil construction work is over and finishing work is started, and we start to install the our equipments, then they do the second site visit. Griha officials do second site visit, obviously with the same reason, monitoring and suggestions. Then when all the work has been complete, building we handed over the building, then we have to submit the documents about document shows actually is the evidence that we have implemented or comply all the criteria which we have committed. So documents may be in the form of drawings, tender documents, specification of the material or equipment or purchase order or photographs. So all the documents we submit to Griha Council, obviously through online. And after checking the documents, Griha officials do the third and the final site visit, and according to that documents they check or monitor all the buildings and see whether we have done properly or not. So after ensure all these things, they do that they give that documents to the external evaluator. External evaluator is the third party who has not any relation with the client or Griha people. It is a third party who do the evaluation of the building according to their documents, and according to that document he provide that external evaluator provide the rating to the building, which is, but that is a provisional rating which is valid for 1 year. After 1 year, client has to do that audit of the waste management, water and energy audit, and he submit all the three audit reports to the Griha Council. And as per the audit reports, that audit report, that is the actual data of the building, that according to that actual data of the building, um, Griha Council gives the final rating to that building, and which is valid for 5 years. That final rating is valid for 5 years, and after 5 years, for every 5 years, client has to submit the audit reports. Same audit report, energy, water, and waste management. That audit report to the Griha Council, and they can renew their rating after each 5 years. So these are the rating processes. So first is the design process, design, then construction, then operation, and then maintenance part. So these are the green building rating process we can see here. So other Griha rated projects, I have discussed 2-3 Griha rated projects earlier. Now I will show other Griha rated projects. These are only photographs. This is the IIM Raipur. I was consultant here. It is a campus of IIM Raipur. It is registered for Griha LD. LD means large development. Large development means it was a campus development, so that they have registered for Griha LD. The site area was about 250 acres. So it is now completed, and they have started the classes here. Last 2 years they have started the class here. So this is the IIM Raipur. This is Nalanda University, Bihar. I am also consultant here in the Nalanda University. This is also registered for Griha LD. Site area is about 450 acres. And this is the IIT Kanpur building, which I have shown you in the previous slide. Center for Environmental Science and Engineering, IIT Kanpur. You can see the closed view of that building and see that pergolas and the solar panels, how they have put in the horizontal surface and how they have incorporated that trees in their design. This is the same photograph. This is the chemistry lab of that building. You can see that they have incorporated daylight with the artificial light in that lab, and you can see very good daylight is here. Suzlon One Earth Campus, Pune, Maharashtra, 5-star rated building. This is the photographs. DMRC building, station cum commercial complex. Here at the design stage, consultant did that simulation and all for that building, and he has brought down the tonnage from the 1500 TR to 875 TR, and so that he has saved 6 crore rupees at the initial stage, at the design stage. This is police training school at Tasgaon, Maharashtra, 4-star Griha rated building. This is the hotel chain of the ITC at Chennai, Grand Chola ITC Hotel Limited. 5-star Griha rated building, and I was the part of the team when they have designing that building, and for the consultancy part when I was in Terry. This is the Fortis hospital at Gurgaon, 4-star rated. At Sikandrabad, Rail Nirman Nilayam, 3-star rated building. Sidbi Training Center, Bhubaneswar, 3-star rated. Mumbai, 2-star rated building. Indira Paryavaran Bhavan, New Delhi, 5-star rated. Akshay Urja Bhavan, Hareda, 5-star rated at Haryana. Software Development Building 1, Infosys Limited at Hyderabad, 5-star rated. 5-star Griha rated. Civil Services Officers Institute, CSOI Club Building, New Delhi, 3-star rated. Administrative Building for Pimpri Chinwad New Town Development Authority, Pune, 5-star Griha rated building. So why I am showing you this photograph? Just wanted to tell that now people are constructing green building. It is not very new thing. All around the India they are constructing, so we can also do that. So that's the purpose of that. And for more details, you can visit Griha website www.grihaindia.org, or for more detail, you can contact me at my email ID gec.msahu@gmail.com, or you can call me or WhatsApp me at my number 786991530715307. And thank you so much for your kind attention. Thank you.
Dear participants, please unmute yourself and you can interact with Dr. Meenakshi Rathod. Phone is cut off.
Hello.
Hello. Please, all of you, mute yourself and you can interact with Meenakshi Rathod.
Hello, Meenakshi madam.
Just wait, sir. Madam is unmuted herself.
Yes.
Yeah.
Hello.
Ma'am. Yeah, Vijay Kumar garu, please interact with Meenakshi ma'am.
Hello, madam.
Yes.
Madam, good morning, madam.
Good morning.
In your present, you have explained very neatly about green building aspects. Madam, green buildings can we use face materials? And
Sorry.
one of the can we use phase change materials, PCM,
Phase
for
change
building
materials.
construction,
Hello.
build for architecture? Like we can
Yes.
provide the
Yes.
PCM.
Yes. PCM. You are talking about PCM, phase change material.
Yes.
Yes, it is a normal building like we do in the standard building. We just introduce the optimize the things, everything we optimize. Otherwise, it is a normal building. You can use any insulation, any type of material which we use in the standard normal conventional building. So you can use that.
Okay. Okay. Thank you, madam.
Yeah, sure. Thank you.
So anybody is interested to dear participants?
Madam, the
Matthew.
curing methods you have told earlier. And what is the best curing method for this concrete? What is the best method for curing?
Um, Normal which I have shown in my slides, and we can also do the sprinkling. There are some equipments are available for curing where they do the sprinkling of water, so that when water comes with the pressure we can use that. So with the little amount of water we can cure that beam, column and all those things.
Okay. Thank you.
Yeah, sure. Thank you.
Still anybody want to interact with Meenakshi Rathore garu? Meenakshi Rathore ma'am, nobody is asking the doubts, so we can conclude the session. So
Sure.
thank you ma'am for accepting our invitation to give an expert talk on green buildings. So though you are a civil engineer, you communicated this related to this solar energy. So it will be very useful for the construction field. So thank you ma'am. So we'll send one email to you. So you fill
Sure.
that form ma'am. So
Okay.
later we will send one link to you. So you go through that link ma'am.
Okay.
Thank
Sure.
you.
Thank you
Thank
so
you
much.
for.
Thank you, everyone. Thank you.
Now you can leave ma'am.
Okay. Thank you so much. Thank you, everyone.
So dear participants, all of you join at 2 p.m. So we have the session by Professor V. Sivareddy on 21st century challenges in education. After that, there is a valedictory session. So after that, we will give exam link for you. So all of you prepare well for the exam. Exam is a multiple choice questions. Around 60 questions will be there. So you can easily attempt the exam. So thank you.